Here we go, guys. The end of Algebra 2B. Getting ready for that final exam. Here we go. Just remember, the exam review is worth 20 quiz points based on effort and accuracy. Yes, you could just copy this, but that will not be getting yourself prepared for the exam. So try to do these on your own and check them. Having said that, we got the fifth root of 32, the fifth root of x to the 10th, the fifth root of y to the 25th. So we got to remember, this really boils down to 3 different problems. So we busted up into 3 problems. Now, what I taught in class was Numberland, Letterland. So we got to figure out what is the fifth root of 32. Well, 2 times 2 times 2 times 2 is 16, so times another one is 32. So I know this turns into a 2. Now how do I figure out Letterland? Well, you put the power of the radicand over the index, and you reduce. So x to the 10 over 5 is x squared. Same thing here, 25 over 5 would give us the 5. And there's our answer. Simplify. Well, we got to multiply the bottom by the conjugate. If we multiply the bottom by that, we got to multiply the top by that. So we distribute in the top. 40 plus 10 square root of 2. And then down here, if you remember, we don't have to FOIL. We can just fool, because the O outside inside will just cancel. So 4 times 4 is 16. Negative times a positive is negative. Square root of 2 times the square root of 2 is actually the square root of 4, which is just 2. 16 minus 2 is 14. Now notice this, a 2 can go in all of these. So we're going to reduce it to 20 plus 5 square root of 2 all over 2. All over 7. Almost made a mistake right there. Okay, so there we go. Number 3, graph. Well, first of all, we have to look at this and realize that we're supposed to know somewhat by memory what the parent function y equals the square root of x looks like. However, if we just take a minute and pick our favorite square root, square root of 0 is 0, square root of 4 is 2, square root of 9 is 3, we get a general idea of what the parent function looks like. So 1, 2, 3, 4, 2, 9 would be here, 3, and you can see the general look. Now, what does this do to it? Well, I'm going to rearrange this as negative square root of x plus 3, so there's no confusion about the 3. We're going to put that in the back. So that is not your letter A. Letter A is always in the front. We have a negative here, which flips it over the x. So I'm going to just do a pretty good job reflecting it over the x-axis. Plus 3 moves this one up 3. So that point 1, 2, 3 is here. I'm going to go with the grand finale, just like this. So my pink little drawing there is my final answer. Okay, number 4. If the graph of y equals the square root of x, which we just did, has been translated left 3, so let's stop right there. That means we need to adjust this one step at a time. That would be x plus 3. Remember our rules. Up 2. It's not underneath the square root. So what would the resulting equation be? Hint, sometimes D, this letter, is written in the front. So I could also say y equals 2 plus the square root of x plus 3. These things are the same. Let me make sure that's good and focused for you. Number 5. Let g of x be the square root of x plus 2. H of x equals 2x. Remember, find the expression for g of h of x. So we got to take h of x, which is 2x, and put it into g. How do you do that? We're going to put that 2x right where that x is, so it would turn into the square root of 2x plus 2. Just a quick little substitution. So that equals that. All right, page 1, done. Page 2, number 6. Solve. Look out for extraneous roots. That means you got to check your answers on these square root problems. Whenever the variable's hidden underneath the square root, you got to plug them back in to see if you have extraneous roots. Well, let's just solve this. Remember, we're going to square this to get rid of the square root. That's the easy part. But we also have to square this side. Remember, you can't just square that individually and square that individually. It just will not work. So we got to square that binomial. So we get x squared. I'm going to go outside inside is negative 4x plus 4 equals, I'll just transfer this down a little bit. I'm going to set this equal to 0 because we see a trinomial lurking. So x squared minus 5x minus 24 equals 0. Fortunately, we have a God-of-1 trinomial, so those are easier to factor. X, two factors of negative 24 that add up to negative 5 would be negative 8, positive 3. We're not done. Now we got to look at this and say, what would cause this to be 0? Well, that would be 8. What would cause this to be 0? Negative 3. We'd be done, but we got to check our answers up here. So let's plug the 8 in. 8 minus 2 equals the square root of 8 plus 28. Well, that's 6 equals the square root of 36, and we go, yep, so that works. Now we're going to plug in the negative 3. Negative 3 minus 2 equals the square root of negative 3 plus 28. Now this is a very confusing thing in math, but when you're plugging things in, you're only supposed to think of, when I look at that, I'm only supposed to think of the principal root. So the principal root is the positive root only. So the square root of 25 is 5. And we're not to think of it as a negative 5. And that's a very tricky problem, but that would make this an extraneous root. Remember, when you plug these back in, you're only looking for the principal roots. That's the key. All right, number 7, 175 rabbit on a farm. Population is increasing at a rate of 3.1% per month. Write an exponential growth function. So our general equation is in some form like this, 1 plus r to the t power. So we know this is what we're looking for, represents the number of rabbits. That's this. So our initial population is 175. The rate is 0.031, so if we add that to 1, we get 1.031, and that's to the t power. So, pause that a minute. Well, I think we can keep going. So, per month, so we let our t equal 1 month, and it says on that farm after X months. So be careful, they might have an X here because they're telling us to use X, but regardless, that would be our variable up here. All right, let's go on to this one. Find the equation of the inverse of the function, this. All right, so this right here is our y. So y equals log of 3x. Now, what we were taught when we learned this was, this means turn it into an exponential equation, which means just follow the rules. Well, if I'm going to reverse this a little, remember if there's nothing down here, there's a 10. And I like it written this way because I remember to go from my base to my exponent to my answer. So 10 to the y power equals 3x. And we are done. Those were the book's instructions. Solve. Common bases, happy places. I have a 4 and a 16. I'm going to change that 16 into 4 squared. And that's x plus 1. Power to a power, we multiply. 2x plus 2 equals, and this guy is just sitting there already with common bases. So the bases drop out. That means this, 2x minus 3, has to equal this, 2x plus 2. So then I'd subtract 2x. Now watch what happens here. Add 3. I get 0, because all this cancels, equals 5. That is a false sentence, and our variable disappeared. That means there's no solution. So be careful for those. But if you, most of the time, you're just going to get an answer for x. But this is a little twist. Solve the equation. Base, exponent, answer. 3 to the negative 4 equals 3x plus 2. Now we just have to solve for x. A little bit of a complicated problem, but what is 3 to the negative 4 power? Well, that's 1 over 3 to the 4th, which is 1 over 3 times 3 times 3 times 3, which is 1 over 81 equals 3x plus 2. Now we have to subtract 2 from both sides. So I'm going to go ahead and jump the gun a little bit. I know that I'm going to have to add 1 over 81 to negative 2, but I'm going to make negative 2 negative 162 81s, because I know I need common denominators. So this right here equals negative 2. Just reduce it, and I knew I needed it. So if I added those together, I'd get negative 161 over 81 equals 3x. Now I would divide this by 3, but that would cause a mess. So I'm going to multiply by 1/3, multiply by 1/3. I wish 3 went into 161, but it doesn't. So we multiply across, and we get negative 161 all over 243. Woof! All right, nasty little guy. All right, next problem, number 11. So the first thing that we look at when we look at this is we think of this as exponential growth, because we should remember that this is just a play off of f of x equals ab to the x, and if b is greater than 1, we have exponential growth. With that being said, we can get started by just knowing, start with our x, start with our x being 0, because we're going to find our locator point. So 2 to the 0 power times 3 equals y. Well, 2 to the 0 power is 1. 1 times 3 is 3. So there's our locator point, 0, 3. Now if we recall exponential growth, we should be able to just draw it in. But I'm going to go ahead and kind of grab one like negative 2 for x. So I'd get 3 times 2 to the negative 2, which is just 3 times 1/4, which is 3/4, or 0.75. So negative 2 up a little. But if you remember, these are your generic parent functions of exponential growth. Now I'm going to go ahead and pick in a positive 2, just to get an idea. 2 squared is 4. 4 times 3 is 12. So that'd be 2, and that'd be way up here. And there you have it. Now notice what it says. What is the average rate? That means slope on the interval negative 1, 1. Well, that means, and I should have done it here. I really should have. I should have put negative 1 in here and 1 as one of these original points, but oh well. So if I put negative 1 for x into that problem, I get 3 times 2 to the negative 1, which is the same thing as 3 times 1/2, which is 3/2, because that's 3 over 1. And I'm going to plug the 1 in. So that's pretty easy. 2 to the first power is 2. 2 times 3 is 6. So really what it's asking for is the rate of change between these 2 points. So I guess the graph was unnecessary. We could have just went for these 2 points and then found the slope. So our first point is negative 1, 3/2. Our second point is 1/6. So just to check it out, negative 1, 3/2, negative 1, 1.5, 1/6. Very accurate. So here's my x1, y1. Here's my x2, y2. And the slope formula is right here. So if we just plug things in properly, we're home free. So 6, y sub 2, minus 3/2 all over x sub 2, which is 1, minus, careful those double negatives. So what I'm going to do is I'm going to turn this right here into 12 halves. So 12 halves minus 3 halves, all over 1 plus 1, which is 2. Now I'm going to concentrate on the top. 12 halves minus 3 halves is 9 halves, divided by 2. Now, I'm going to turn this bottom into a fraction, because I know if I take a fraction, divide it by a fraction, I multiply by the reciprocal. And that would give me 9/4 for the slope. That was a pretty busy problem. All right. I'm going to do a couple more and then stop it, because YouTube has a hard time processing it if I go a little over 15 minutes. So this says, rewrite the following using your laws of exponents. Well, remember, division means subtraction. So this is where I taught you guys the mall. You get out your log splitter, and you apply your laws, and it splits it into 2. So this is log of x cubed minus log of yz to the 4th. Now, they really want you to use the laws plural. So we're looking at this, and we're like, hey, wait a minute, I remember law 3, I can put that in the front. Because if it's a multiple choice question, I doubt you're going to have this, because there's more work to be done. We can put the 3 in the front. And now we've got minus. Now here's where it gets a little complicated. It's minus all of this. So I'm going to go minus parentheses. And then if you notice, in the box, these are connected by multiplication. So the mall keeps happening. The mall hits this, splits it into log of y. Remember what multiplication is? It's addition. Z to the 4th. Now, I would distribute that negative now so I don't forget it. So I'd get 3 log of x minus log of y minus log of z to the 4th. But you got this little law 3 sitting there saying, hey, look at me. So I'm going to try to squeeze it in here. This didn't change. This doesn't change. And then that comes in the front. And there's our final, most simplified answer. And that's going to finish part 1. 1 through 12.